Well, thanks guys for having me. It's the first time that I'm speaking at DConf. Super excited. You have to excuse me, I'm super jet lagged. I landed from Hong Kong this morning, and so it's 2 a.m. for me, I think. Not my usual time to do mental stuff. Packaging your D app. So not packaging your dApp, as many of my colleagues made fun of me. It has nothing to do with that. So packaging, I think it's a often understated problem. Right? You make an app, and if you're in the D community, everything is fine. Everybody uses dub, and you just tell them what the name is, and dub build, and you're done. But if you want to share your app with people outside of the D community, you have to package it with all the dependencies, and that's not so trivial. And so one first question to answer. So you want to package your D app. What's your app? Is it a web service, or is it a CLI, or maybe it's a user interface? I haven't seen many D programs with full-fledged UIs. So stick to these two categories. And then if it's a cloud app, then the question is, what provider are you building it for? Any of these, and they have their own. Some of these have their own packages that you can build. If it's a CLI, it's even worse. Like, what are you going to build it for? What distribution do you want to use? What packaging do you want to use? Everybody recognize these symbols here? We have Brew, Flatpak, Snapcraft, Nix, Nougat, App Image. macOS has their DMG thing, Dub, of course, Yum, Chocolaty, Debian over there, Windows, Aardvark, apparently. I've never seen a package. But anybody, any Arch users? Oh, well, cool. I'm glad I put it in there. So, after proprietary algorithm on that matrix, you get this. These are the principal components to span that whole space. Okay, this is basically my opinion, right? There's no algorithm here. So if you have Docker, Nix, and Chocolaty, you can cover most of the cloud and distributions that I just showed. I think everybody knows Docker. Nix, who knows Nix? Okay, that's good, actually. Yeah. And Chocolaty, any users? Okay, a little bit of everything. Docker, I think everybody knows, right? Docker users? Okay. Actually, I think we have the crowd covered with these axes. Okay, so Docker, short introduction for who doesn't know Docker. So you get one container, and that's great because you can do all your local testing and your cloud deployments with the same container. Right? You don't have any surprises. I think that's a good thing. Your container has all the dependencies, so once you have your app packaged, everything is in there. It's convenient for web services. The cloud providers, they often support it, and you just upload your Docker container and it's up and running. I've seen it used for CLI tutorials. You do a Docker run, you get a bash prompt, and the tools are in there. But then if you want to use those tools in during your own development cycle, it's not so easy. You can map a drive and stuff like that. So Docker, if you consider it a package manager, they have a hub, a registry for their packages, similar to Dub, right? So it's supported in the cloud, and it's usually a good way for web services anyway, because once you have a Docker container, they can be scaled, right? If you architect your app correctly, the container gets multiplied over the instances. So for D, what does that look like? The minimal example is this, right? You used the DMD official base image. You copy your sources, you compile the sources, and then you run the executable. So this is the minimal Docker file, and that works, right? You can do Docker build, and then you Docker run, and your app runs. But then suddenly, we get more complex. First of all, the simple hello world, the container is 560 megabytes. So why does that matter? Well, it matters because this is the container that will be running on the web service in the end, right? There's a download cost to it, but that's a one-time cost, so maybe that's not so interesting. But the container has all the tooling in there, so I don't know about you, I'm not so comfortable having all the tooling on my server that is facing the web. Actually, if you go to the DMD one and you do a systemctl, there's actually services running on it. So you don't know about it, but if you just take a base image and you put it on the web, you don't know what else is running in there. And so what is a good base image? Well, the best one is Scratch. It's a non-base image, actually. There's 0 bytes. But you have to put everything you need, you have to put it in there yourself. And so a very naive way to make sure that everything is in there is to do LDD recursively. Everybody know LDD? The Linux loader. So if you do LDD on an executable, it dumps the dependencies. And if you do it recursively, you dump the dependencies of the dependencies. And if you copy everything over, yeah, then you should have everything. Or do you? So let's try that. Okay, we do a multi-stage Docker file because we want to build using the official base image. We do not want to have the build tools in our running container. So in this case, I use Dockerize. It's a script that somebody wrote. It's a Python script, or somebody. It's Lars something. And so we can install it during in our Docker file. It's a Python script, so we need to install some Python dependencies. And then, same thing, we copy the D sources, run the decompiler, then run Dockerize on the executable, and that'll do the recursive LDD, copy all the binaries into the output. And then finally, our container will be from scratch. We copy the output and run the executable. This works great, but it only works for dynamic libraries, right? If you have other files that you need from the base image that don't appear in LDD, then it won't be copied. Oh, the wrong way. Oh yeah, also you might not want to use DMD, you want to use dub. And then this is a little trick. If you just use dub naively, you put a dub build in there, then every time your source changes, dub will pull down all the dependencies again because of the way Docker caches. Docker caches by line, and if any line changes because of what is before it, everything will be redone and the cache will be thrown away, right? So it would re-download, rebuild all the dependencies. And so one trick that you can do is you copy over only the dub JSON or SDL, then do a dub build. It will fail, so we'll make sure that it always succeeds. And then we copy our sources and do the actual build. So then we get a nice cache that has all the dependencies in there. And when your source changes, only your app is built. Okay. So that was Docker. Now Nix.
Just one question.
Oh yeah? I'll go back before I spoil.
So instead of copying all the dependencies, why not simply use static linking?
Well, but it also downloads the dependencies, right?
No, I'm not talking about the dub dependencies, but the dynamic libraries.
Yeah, you could do that. Well, if everything has statically linkable libraries, you can do that, yeah. So Nix. For who hasn't heard about Nix yet. So Nix is actually two things, right? So Nix is I will be talking about Nix, the functional package manager. Incidentally, the Nix packages are also written in the language called Nix. And then there's also a Linux distribution called Nix OS. I will not be talking about Nix OS. Suffice to say that Nix OS uses Nix, the package manager. Right? I like Nix because it's cross-platform. It works on all the Unixes, macOS, FreeBSD. I even tried it in Windows subsystem for Linux. So it's kind of funny. So that works. And similar to Docker, you get one package, and that package should be identical to the bit, actually, right? So it should be identical for local testing and for cloud deployments. The way Nix works is you create an expression. It's a functional language, right? So you create an expression, and so f of X equal Y, right? And X are all the inputs for your package. So these include the build scripts, dependencies, any sources, flags, compiler versions, all of that. That's your X. Then you define the function, and then Y is the output. And all the output ends up in the Nix store. So on your, if you use Nix, then on your root folder, you will have a folder called Nix inside a folder store. And all your packages are in there. There is no globally installed package. And all the paths in the store are the hashes of the inputs for that package. So what does that mean? That if you have a package, you define how you build your app, then if any dependency changes, that hash will change and that path will change. And so you can have multiple versions of a package, of a compiler, of a library, side by side, because the path will be completely different. They will also include the name and the version of the package, but Nix doesn't care. That is just for human readability, so that when you list the Nix store, you can actually recognize what's in there, but it's not actually used. And then, similar to the Docker Hub, you can upload your package to the Nix packages repository. You don't have to, right? If you have your package, you can just tell people where to find it, and they can use it as is. You can also merge it into the Nix packages repository, and then people can install it they don't need the URL, they just need the name. That's a trick. Very cool thing about Nix is it does automatic runtime dependencies. So you don't have to do LDD, you don't have to do a trick like that to find out what files or libraries are used. Nix does that for you. And this is how you install Nix, if you trust Nix. And so what does that function look like? So this is Nix language. It's a functional language, so many patterns maybe people are familiar with. Start with with. With pulls in a Nix expression and puts it in the scope. So in this case, we have the parentheses. Parentheses are normal parentheses, nothing special. The accolades, those are sets, kind of like JSON, right? So those are key value things. And the import statement takes a Nix file, which can be an alias. This case, it's the alias for the Nix package repository. The Nix package repository actually evaluates to a function. We are calling that function with the empty set, and that's all. The result of that function is a set itself. It's all the packages. So DMD is in there, dub is in there, LDC is in there. And then with we pull all of that in the local scope. So after the first line, we have DMD in the local scope. So then I say, okay, now I'm going to make a derivation. A derivation is that function f that I described, right? So this is how the package will be declared. We have a name there. We have built inputs. So we say DMD is one of the built inputs. Square brackets is an array, so space delimited. Our sources in the local folder. This is how we built using DMD. These are bash scripts. And this is how we install. And installing means copying to the Nix store. And then the $out is a variable managed by Nix that says what the path is, right? It creates a path based on on the hash of all the inputs. And you put the binary in the bin subfolder. And once you have that, you can install the app with nixenv. F means that -I means we want to install. F means we want to install from file. And then hello dnix is the file that you saw here. So instead of by file, you can do by name. So if your package is in the Nix packages repository, you do by name. And if it's online, you put a URL there. That works as well. So this works fine with D. And now we do it with dub. And dub is a little bit special. Nix is a bit special because the build is completely deterministic. There is no arbitrary internet access. You cannot access anything outside of the Nix store. And this is how builds end up being completely reproducible. Nix even goes so far as resetting the time on all the files to January 1st, 1970. So if you build a Nix package and I build a Nix package, we'll get the same bit by bit executable. But it makes it hard for dub because dub wants to do internet access. and wants to download the packages. And then, of course, if you say I depend on 1.0, then a week later, it might not be the same thing because the DAG might have been moved. So that's a bit tricky. How we solve that is by making derivations for all the dependencies. So not just our app will have a derivation, we'll make derivations for all the dependencies. And what does that look like? So for each dependency, we tell Nix to check out a particular version from the Git repository, and that's the one that will either dub build or dub add local. Do people know dub add local?
Unfortunately.
Yeah, okay. All right. So add local is you can preempt dub from downloading by just pointing it to a local folder. So you tell it, okay, here's a folder with sources, and this is this package of that version, and then if that is indeed the version dub once, it will no longer download. It will just believe what you just told it. And then I made a tool called dub to Nix that actually takes a dub selections file, converts it to Nix expressions. And so that's the URL that gets you there. Incidentally, Nounly is a website that I built in Vibed using dub, using Nix. So eat your own dog food kind of thing. And so Nounly is a URL shortener where you put a noun and you get a URL. And so this is, if you want the tool, you can go to nounly/boy. It's a random noun, by the way. It'll change. It's valid for a day. Questions about this? How's my time, actually? All right. So this is how you use it. We'll import my dub derivation, a new function that I wrote. It's in the dub Nix file. So we import that file first, and then we declare a dub project instead of what we did before with make derivation. We just have to say a version number because that's not in the dub JSON file. We still point to the sources, and we say what the dependencies are. If you don't say what the dependencies are, it will default to the selection Nix file, which is the file that dub to Nix creates, right? And then you can install it using nixenv again. So this is actually dub to Nix. If you want to install it, once you have Nix, you can install it like that. And this will pull in all the dependencies and everything. And you can, to use dub to Nix, you just run dub to Nix save in your folder. And this is the same pattern that they use for go to Nix. There is an npm to Nix, there's a yarn to Nix, pnpm to Nix, so it follows same pattern. This is what the selection file looks like. So this is the output of dub to Nix. And the important part is that it calculates that hash that Nix wants, because Nix doesn't want any surprises. It will still fetch from the internet, but only if the hash matches. So it will, if somebody moves that tag in Git, the build will fail. And then you can actually use Nix to build Docker images. Okay. And the way to do that is you import the package that you wrote. That is your simple derivation. You give it a name. Here I give it an alias hellod. And then if I use the build image function, and my command is hellod/bin. Again, hellod, like I said, it refers to a path in the Nix store. So when you do $accolades hellod, Nix will put in there that actual calculated path with the hash in it. And then the bin/hello is where the derivation has copied the executable to. And so when you do this, you get a minimal Docker image with all the dependencies calculated by Nix. It takes care of all the runtime dependencies. And then lastly, chocolaty, because you might not be happy with running Nix on Windows subsystem for Linux. So for Windows, you should probably use this one. It's a package manager for Windows. It uses NuGet for the packages, but it has optional scripts. And basically, those scripts can do anything. So they're not really reproducible because they might delete something or registry. Yeah. And in typical Windows fashion, this is the short line to install chocolaty. I have no idea what this does. I copy-pasted from their website. How do you use it? So that is the good part. It's similar, right? You use an XML file. You declare your package, your version, author. This is the minimal stuff that you need. optionally dependencies. These dependencies are by name and version though, right? So again, there's a little bit of trust that you need, that that is what it's supposed to be. And then the files that you want in this package. And finally, this is how you use that. So Choco New creates a skeleton project. Choco Pack packages your package, and then people can install it either from folder or from name if you upload your package to the community feed, and you can install uninstall as well. This is a summary, a bit too much to go through. Each have their advantages, disadvantages. If nothing else, take a look at Nix, because also for development, Nix shell is great. Nix shell actually installs a package in the current shell only. You get a subshell with that package, and then if you exit the shell, you can't access it anymore, so it's beautiful to use that for development. You have multiple versions for DMD, for example, depending on the folder that you're in, you can do that. Yeah, these are all the references. This is the presentation, if you want it, anomaly/file. That's it. Thanks.
All right, thank you, Leo. It looks like we've got time for one or two questions, if anybody has one over there.
I was concerned about security, and can you sign Nix packages, or can you sign what was the other, chocolaty?
Yeah, chocolaty uses code sign certificates, right? The usual Windows. You apply for a certificate, you get it, and then you can sign both the executables and the final package with that code sign certificate. Nix doesn't have signatures, but everything is hashed, right? So there's nothing in Nix that doesn't go through a hash.
I'm thinking about how do you verify that the package that you put somewhere is actually the same that somebody else is installing on her or his computer?
Well, because everything follows that hash. So even when you declare a package, all the inputs of that package have to match that SHA-256. So it's impossible that somebody replaces a file. Your package would refuse to build because one of the inputs doesn't match the SHA in your derivation. And so all the way, it's, turtles all the way down kind of thing. Your final package that you get will have a SHA that is actually covers all the dependencies up to, the little file in glibc or whatever it depends on. And if you put it in the Nix packages store, then that is referred to by the Git SHA, actually. Nix packages store is a Git repository, and stuff gets merged into master. If you want to add your package to the Nix packages repository, it gets merged into master. That's the version of the Nix packages repository, and then everything follows the SHA from there. Yeah, it's a good question.
All right, but we will have to cut it short there. We're out of time, so thank you again, Leo.
Thanks.